So in 2011, John Hopkins issued a media release, as we've heard, detailing a study on hands-free faucets titled, "Do Hands-Free Faucets Harbor More Bacteria Than Manual Ones?" Due to the importance of this issue to the plumbing engineering community and many other industry stakeholders, ASPE convened a meeting of industry leaders back last year in June in Chicago to better understand the study design, evaluate the validity of the results of the study, and to determine next steps. As a result of that meeting, where I think many of you were involved, we have started a project to one of the issues that came out of the meeting, or suggestions, action items, was to address this issue of all the studies we have on this issue of electronic faucets are in-field studies. And so wouldn't it be good to have a controlled environment laboratory study where we look at this issue and can adjust variables and try to get more information and piece together, do we truly have an issue or not? And so we have a research task group together, pulled together for this. Some of the panelists are actually involved in that research task group, and we are in the process of developing a laboratory design protocol to hopefully get some more answers to this question. I always say that, the poor faucet manufacturers are at the end of the system, and so they always seem to get hit with all the issues. I don't know if that's because at the end of the system or there are actually issues, but we'll see. And that's what we're going to try to answer with that research study. So as this is going on, simultaneously, ASHARE Standard Project Committee 188 members have been hard at work updating their Guideline 12, reducing the risk of Legionellosis associated with building water systems. As we move forward with water efficiency provisions, it is important that plumbing professionals understand how we are being challenged with exposure risks from dangerous pathogens, and also understand the design and maintenance strategies that work to mitigate those risks. First, allow me to introduce our panelists. Dr. Jamie Bartram has been a professor at the University of, or is a professor at the University of North Carolina at Chapel Hill, and is the director of Water Institute of UNC. Dr. Bartram has over 20 years' experience of international policy, research, and advisory work in public health and disease prevention, especially in relation to environment and health and water supply and sanitation. Congratulations are in order to the Water Institute of UNC for being a founding member of the U.S. Water Partnership that was announced by the U.S. State Department on March 22nd, which we heard about earlier, World Water Day, and discussed earlier today. I have to say this, Jamie, I don't know if you remember me, but I remember Jamie when he had a ponytail. It was the last time I saw him, so I couldn't resist, Jamie, I'm sorry. Next, Dr. Joseph Cotruvo's career ranges from water chemistry and technology, federal and international regulatory development, health guidance, water science, technology and toxicology research, and water and wastewater system oversight. He is president of Joseph Cotruvo and Associates, LLC. His PhD is in physical organic chemistry from Ohio State University. If you heard where I graduated from, it's too bad, Joe, that you had to, I didn't know you were a Buckeye. He was first director of US EPA's Drinking Water Standards Division and also director of US EPA's Risk Assessment Division in Toxics. Dr. William McCoy is co-founder of Phigenics, LLC, a solution provider for problems associated with building water systems. For the American Society of Heating, Refrigerating, and Air Conditioning, chair of Standard Project Committee 188, writing Standard 188P, Prevention of Legionellosis Associated with Building Water Systems. Previously, he was elected to the Environmental Health Committee and then served as chair. Most recently, Bill has been elected to serve a 4-year term on the ASHARE Research Administration Committee, which manages an annual $3 million budget. Mr. Charles White is a 1978 Purdue graduate in building construction and contracting with an emphasis in plumbing and HVAC. Chuck has over 30 years' experience in plumbing, mechanical, and electrical contracting work, as well as working for small engineering firms in the South Bend, Indiana area. His experience covers a range of systems from single-family residential, multi-family apartment facilities, office building systems, and up to large industrial process piping and heating systems. He has taught plumbing apprenticeships for 21 years and has been a member of the North American Technician Excellence, NATE, Technical Committee for 10 years. Dr. Janet E. Stout and Mr. Tim Keane were previously introduced and complete our panel. Wow, what a panel. This is going to be a great discussion. You can see the longer version of our panelists' bios in your program. Please welcome our panelists. I have a feeling a lot of you are out there going to dying to ask questions, but give me this benefit here of asking one question, and then I'll open it up to you folks. So let's start with one question I'm going to ask each of the panelists to address, and hold yourself to, I think, 3 minutes, please. But practically everyone here in attendance today has a common interest: the safe delivery of drinking water for human consumption. What is it that keeps you awake at night, worrying about what can go wrong in terms of the potential for contamination of potable water in our plumbing systems? Jamie?
Shall I lead off, Jim? I have to say, when I was told that we were going to be asked about what kept us awake at night, I started to wonder about what kind of conference I was coming to. That only gets worse because one of the things that helps me sleep at night is a woman, and she's not my wife. And I think I have to explain that, don't I? That's because a few years ago, when I was working with the World Health Organization, I had a counterpart in UNICEF, and we were lamenting one evening how one always got addressed by your Director General at a late hour of the evening, who required a briefing note on that something was desperately urgent. And we were comparing notes on how to control the overload that I think many of us are familiar with in an increasingly connected and urgent world. And she said to me, so it was a she, that's why it was a woman that keeps me awake at night, or helps me sleep at night. She said to me, you know, in the end, when it gets too late and there's too many things to do, I asked myself, how many more children are going to die if I don't answer that request? And if there aren't any, I can sleep. So I sleep quite well at night. Having said that, you know, those of us that are involved in this room or are gathered here today, we are engaged in a line of business that does save lives. You know, we have an impact on real people. And therefore, it wouldn't be unreasonable that there were things that kept us awake at night. And I think there are probably two things that come back to me, if you like, the things that would keep me awake at night. And one of those is the apparent inability to overcome the persistent underinvestment in water and sanitation, both in the developed and the developing worlds. In the US, and I know it's also true in the UK, the replacement period for major infrastructure is something like 300 years. I mean, I think water engineers are marvelous people, but I don't believe those pipes they bury in the ground are going to last 300 years. I don't think that fits. And in the developing world, we see hand pumps that are designed to last on top of wells for perhaps 1 or 2 decades that break down within 6 months and are then not repaired. So one is the under attention to investment and to maintenance. And the second is very straightforward. The human race, as we enter the 21st century, still insists on managing its own waste by pumping it into our environment, ready to come back to each of us. And I really think that we ought to have a better way of protecting our own health than doing that. I was going to make a pun that Janet, you commented on the different pronunciations of water. And it struck me in one of the presentations we had today, there was a comment about the delivery of hot water from public lavatories. Now, I don't know if the word lavatory has the same meaning in the US as it has in the country where I was born, but I would never wash my hands in public lavatories.
Well, I think that's a good judgment, Jamie. Good decision. Well, in terms of what keeps me up at night, not exactly, but I think there are certainly issues relative to infrastructure, and Jamie's already touched on that. So I'll move over a bit and say what's particularly challenging is the fact that now that we've pretty much solved issues of waterborne gastrointestinal disease because of source protection, treatment, distribution, pretty well controlled, that it may well be that the major issues associated with water distribution are those of the unintended consequences, the problems associated with growth of organisms in the system like Legionella, and that the risks primarily being from inhalation rather from drinking water. So it's really kind of a ironic turn of events that the fact that a few hundred years ago people figured out how to distribute water to the entire community, and about 100 years ago figured out that they really ought to treat it and filter it and disinfect it so as to eliminate most of the risk of waterborne disease, we can now retroactively say, actually, we've been transporting it as another vector for inhalation-related disease that come from the distribution system. And that's a real challenge. We heard about, both from Janet and Tim, some of the challenges that relate to that. And then that leads me to one last point, and that is, I think sometime there ought to be a conference, a discussion on what will be the shape of public drinking water in the 25 years from now or 50 years from now. Is it going to be just like this? It hasn't always been like this. It's only been about 100 years that water has been treated specifically for reducing microbial risk and distributed. And is that the best way to do it? Is that the most cost-effective? In many respects it is, but there are other factors. And is it the safest way to do it? And so someday I hope we can talk about a discussion of what's the future of water distribution and what's it going to look like, say, 25 years from now. So, thank you.
I'll go ahead and chime in on what's already been discussed as far as one of the issues I didn't mention in my presentation. If you go to Google, and I guess in this audience most people are aware of it, and you Google potable water infrastructure, you'll find many, many, many articles on the age of our potable water infrastructure and the declining condition of our potable water infrastructure. I've investigated myself personally 4 major Legionnaire's disease outbreaks that were directly related to potable water disruption events. Now, this has been in guidelines and papers for many, many years, that when you have a disruption in your municipal supply and you have a turbid water event, that you have an increased risk for Legionnaire's disease. One thing that hasn't been in papers yet is that when these disruptions occur, they give you a really unique footprint. We know cooling towers spray an aerosol, and when there's an event associated with a cooling tower, it can be extremely large. And potable water Legionnaire's disease outbreak events are typically very, very small. When you get a lot of bacteria in a potable water system, a person here or a person there might get it. So you might have 1 or 2 people a week or a month. It might go undetected if it's in a hotel for a year, and it might be a total of maybe 8 cases over a 12-month period. But when you have a municipal water event where you get turbid water coming into a building, you get an outbreak that's very sizable, 10, 20 people within a week or 2 weeks. It's something very similar to a cooling tower. So we know we have issues with municipal water infrastructure. The Hopkins paper is a perfect example. They found out by accident about the issue with electronic faucets because Baltimore has municipal events routinely. And they were testing after a municipal event. And back in 2002, when we did our initial study at Hopkins, we also found that information out, that you'll get extremely high levels of colonization And some papers have said, anecdotally, they said, we think after that, the levels will go down. Well, Hopkins found out they don't. And in fact, they can go up after a municipal water event. So code issues, I think we definitely need to improve. And in this case, there is not an EPA requirement for Legionella control in municipal water systems as of now. And there is no requirement for testing municipal water systems. Believe it or not, these 4 outbreaks I was involved in that resulted in large cases of disease. In not one of these cases was there a public notification given. You know, EPA public notification rule says when you have a disruption or a shutdown for 6 hours. Not one of these cases was this. So we can definitely have improvements where we can take existing codes and implement and enforce them better and become more aware of some of the unintended consequences of these issues. Thank you.
I listen a lot to facility managers and building owners, people who are responsible for all the building issues of a modern complex. If you listen carefully to them in regard to the problem we're talking about here, that is building-associated waterborne disease, you will hear a lot of frustration. And the frustration is because most facility managers have no idea about what to do with all the information out there about this problem we're discussing. I mean, it's overwhelming. There are dozens of documents, lots of scientific papers, many experts, all very opinionated about various aspects of the problem. But the real issue is what to do about the problem, given all the information there is to bring to bear on the problem. I think this is at the core of the issue that we're concerned about. So here's what the standard ASHARE 188P specifies in this regard. It's consistent, very much so, with the World Health Organization Water Safety Plan, in fact, functionally identical. And the standard says, to the facility manager, the first and most important aspect is that you must take responsibility for the problem. And it's hard for me to overemphasize how important this is to you folks, and how important that aspect of the standard is. Because unless facility management / owner take responsibility for the problem, nothing happens. The second thing that the standard specifies is that the building facility management / owner appoint a team and assign it responsibilities and accountability for the problem. The first job of the team is to describe the building water system. And to many in this audience, that might sound trivial. It might sound obvious. Well, you're right, it is obvious, and it's obviously not known in most cases. A simple description of the building water system is crucial, and it affects many things, including water safety. It can lead to improved efficiencies. Once the building water system is described, then the team must decide if hazard control is necessary. And there's a process for doing that, which I won't go into right now. Straightforward, scientifically based, very simple. If hazard control is required, the team is required to specify 4 aspects to hazard control: the critical limits, the monitoring method for the hazard control, such as, for example, chlorine residual or temperature, the frequency of monitoring it, and the corrective actions to be applied if the critical limits are violated. Those corrective actions now relate to the hazard control, not the hazard itself. We're almost finished now. There's only 2 more things that the standard requires, and those are verification and validation. Verification is confirmation that this plan that the water management team establishes is actually being implemented. And validation is evidence that the hazards have been controlled by the application of the hazard control. This comprises what must be done with all the information out there about waterborne pathogens associated with building waters. And I think if this were implemented widely, I would sleep a whole lot better at night.
Thanks, Bill. When I think about water safety and the roles that we all play in that, the thing that concerns me and might make me lose sleep has to do with the premise water or the water within healthcare facilities. And my heart breaks every time I learn of a premature or neonate dying of Legionnaire's disease or Pseudomonas infection that baby has contracted as a result of exposure to water from a faucet in a healthcare facility. So it doesn't matter if it's a neonate, if it's an elderly person, or somebody who went into the hospital for a knee replacement. I think we collectively here have the solutions to the problem of controlling these organisms in water systems and particularly in healthcare facilities. So ASHARE 188 does take a step in that direction. What I hope that this organization and others will do is raise that awareness so that there is shared responsibility and shared cost, because it does cost to control these things, and that we apply our knowledge and our desire to have safe water in all of the buildings for everyone in those buildings.
I think if I wasn't losing sleep before this meeting, tonight we're probably all going to be a little short on sleep thinking about this. It's a huge problem, and I represent the contracting world, former plumbing contractor, and we want to do the work right. We want clear guidance. We want simple rules to follow and understand and know what to do and when to do it and what not to do. And if we do have a problem, what do we do to fix it? And that, to me, is what I concern myself the most about. What, as professionals in this industry, should we be doing, and how do we do it?
Thank you, everyone. I think as I listen to your thoughts, you know, I hear concern about the infrastructure and the age and the conditions of our systems, unintended consequences of our systems and all of that, and we've heard that throughout today. I think I'm sort of with Chuck. You can get depressed pretty quick. But I think in listening to Janet and Bill and others as well is that a lot of the information is there. And if we can get it to the folks like Chuck and the building managers and get them to implement that, that's a good thing. And that could help us sleep better at night. So that's the good news I'm hearing. So thank you all for those comments. Very insightful. Before I open it up for questions, I had one anecdotal story I thought you'd enjoy. Is ASPE recently had an educational conference, and the plumbing engineers all came to the conference. And I started to get calls from some of the engineers that they were having respiratory problems and a little bit of fever and all that after coming home from the conference. It's only a plumbing engineer, it's a very small population, but it's only a plumbing engineer that would say to me, and I specifically asked my doctor to do the Legionella test, and it was negative. Now, not many people would know that, but my plumbing engineers were asking for that test, so I was impressed. The downside was I was sort of hoping it was that, because it would have been a great study and a great paper, but I guess I'm happy our members didn't come down with Legionellosis, so that's a good thing. I'm going to open it up. We got some great panelists here, some great information. So, Bob? Oh, by the way, let's keep on the format of giving your name and association, and also if you have a question specific to a member of the panel, please indicate that. Or if you're just asking a general question that anybody can answer. Bob?
My name is Bob Boulware. I'm a consulting engineer with Design Air Engineering from Indianapolis, but also national president of the American Rainwater Catchment Association. Got a couple questions. Biofilm. We've had Dr. Peter Combs, who I shamelessly dropped his name earlier, is a researcher, microbiologist out of University of Newcastle in Australia. He's done quite a bit of work on the benefits of biofilm in a water storage tank. In essence, that the water coming out of a water storage tank is actually better than it going in, thanks to the work and the natural process that goes on with the biofilm. Has anybody replicated that kind of research in the U.S. that you're aware of, and do you have any personal opinions to that effect?
Anybody?
Well, I have kind of a long-standing interest in this field because that's the topic of my graduate work many, many years ago. And fixed biofilms can be hugely productive. I'm aware of some studies where essentially side stream filters were used as biological control for cooling water systems as a side stream. So yes, there can be many positive effects. However, there can also be many negative effects from biofilms, fixed biofilms in storage tanks or side stream filters. And I've seen those personally. So I'll tell you one quick story, and this is just to show the negative side. We know that fixed film biofilms can be productive, but it requires control and a lot of engineering to make them work. On the negative side, I've seen side stream filters that are fouled with biofilm and burp microorganisms and biomass into the system laden with bacteria that are not productive. In some cases disease-causing, and in other cases corrosion-producing. So it's one of those swords that has two sides to it. To make it work productively requires some engineering and some real care.
Jamie?
Well, oh, you're going to?
I think the idea that we have this label of biofilm, and we think of biofilm as either a good thing or a bad thing, may be a bit too much of an oversimplification. And as you were speaking, what struck me is there's at least 100 years of experience of manipulating biofilms for the precise purpose of drinking water treatment. So it's not new use. That's all a slow sand filter is. We see similar work that was done in Colombia in the 1990s that was seeking simple use of biofilms to reduce microbial loads. So I think we need to distinguish about where we see microbial growth and how it contributes either positively or negatively to water quality. Where it's a deliberate process which seeks to remove microbes or nutrients from water, it makes a positive contribution. We are now, and I think every panelist here, most of us in this room, are very sensitive to the hazards that arise from growth, microbial growth of potential pathogens. And that's just another form of biofilm for the most part. Therefore, downstream growth in distribution networks, we might see as a bad thing. I nearly said a good thing, that would be bad, wouldn't it? Whereas controlled growth in a managed environment provides us a mechanism towards water treatment. So the message is distinguish, biofilm is neither good nor bad, it's where we have it and what we do with it.
I would say I agree, and a biofilm on a slow sand filter is great because it is controlled. And however, on the other hand, sort of a wild biofilm, you might say, in the distribution system in a tank, it seems to me there are a whole lot more problems than benefits that could come from that. And as a growth site for organisms, as a site for harboring amoeba, which will harbor organisms, flaking off and producing particulates in the water, which may have microorganisms attached to them. None of those are good things. And so I think from my perspective, I think the goal is to try to keep them out and keep them under control when it comes to the inside of a system.
Okay, I guess
Janet, did you have something? Janet, did you have something?
Nope, nothing.
Oh,
Okay, I guess I got the next one. Craig Salover with Masco Corporation. We're a large building products company with a lot of businesses involved in making plumbing products, faucets and supply stops and supplies. And we're members of the Center for Biofilm Engineering at Montana State, so we've been looking into biofilms and trying to understand those for a variety of our different product companies. And I know that disinfection in water systems is there to try and keep the microorganisms under control, but hardly ever does it kill them all. All it does is keep the levels down. And so they colonize, I would gather, most pipe and plumbing surfaces and form biofilms over some period of time. And I've sat in on Dr. McCoy's, a couple of his meetings at ASHARE, and so I know that there's a lot of things in the 188 and the Guide 12 that are aimed at trying to figure out how do you remediate and make sure you've got appropriate systems in place to keep Legionella in particular under control. As I was listening to Tim earlier, one of the things that struck me in terms of, I guess, your investigation and maybe some of the others, where you found Legionella present in samples from some faucets and shower valves and not others. What I'm wondering is did anybody ever go in from a systems standpoint and sample the interior surfaces of those products to find out if there were biofilms on all of them? Or it was just that you didn't find any in the water sample that you took from them? And the other thing you said, which kind of lit a light bulb from a systems standpoint in my mind, is as you were looking at the electronic faucet at a really low flow rate, and it's got a long line from the supply line that takes a while to fill with hot water, what I'm wondering is from a systems standpoint, as you gradually draw hot water into that line up to the faucet, and then it's shut off and it's not used, that water gets to be tepid because it cools down over a relatively short period of time. And so are there also upstream, because of slow flow rate issues relative to biofilms and various pathogens growing, that contribute to the problem as well? So I think that there's a lot of things we don't understand from a system standpoint well enough yet to understand exactly how we need to deal with them. And then, so you can comment. And my only other question is that I know that water utilities treat all of the water, and a lot of the size of water mains is for fire control. And so we have fire hydrants and so forth, and so there's a lot of expense that goes into treating water with disinfectants for that purpose as well, and a lot of that water is relatively slow moving. And so I'm wondering if down the road we're not going to enter into a world where, as you're looking to do from a healthcare facility standpoint, we end up with much more point of use or point of entry to building control in order to control the microorganisms.
I think, if I can help, I think, Tim, there were some questions directly related to yours, and then maybe the general question about point of use, point of entry will open to the whole panel.
Okay, I'll start off with the point of use, point of entry, where you begin. That is an issue, and depending on your municipal system, you can have some municipal systems. One of the things I didn't mention earlier is, in addition to infrastructure problems, we're having demographic issues, where inner cities that used to be high occupancy may not be. So you can have, and we're having cities where the volumes of residences dropped off dramatically. So you've got water turn issues in those municipal pipes that were sized for the city population 50 years ago that is half of what it used to be. So point of use, point of entry is definitely an option that helps. Now, if you're looking to reduce the bacterial loading, I know I've recommended it to several of my customers, simple, cost-effective point of entry type of filtration helps a lot. And I know people are working on studies of that now, where they've put point of entry filtration on their buildings, and they looked at disruptions and the impact even something like a 25 micron point of entry filter has, because of the reduction in pathogens and the reduction in organics into the building. And when you talk about biofilms, it's a big question. There's a lot of people that have done a lot of different studies on biofilms. Some people have said it's independent of flow. Some people have said you get more with higher flow. My personal experience is if you have good flow and you have good velocity, and one of the things I check when I go into a building is I check the flow. So I'll get my thermometer and I'll get my stopwatch, and I'll see how long it takes to get to maximum temperature. If it takes 3 or 5 minutes, I know I've got a serious problem in my hot water system with flow, and that usually results directly in pathogens. And I'll also check for a simple test. You do total heterotrophic plate count. You won't always have Legionella, but you'll almost always have extremely high levels of HPCs if you've got design issues. So you get water coming out of the faucet at full temperature within a minute, and that's something that we put in ASHARE guidelines, is you've got a pretty well-designed system and a pretty good turn in that piping. And if you go beyond that, you've got water aging issues, and with that resultant bacterial issues.
Jenna?
Just a comment. I think you ended your questions with sort of a statement about, are we, if I got you right, are we sort of headed towards supplemental treatment of building water? And because I've been involved in looking at Legionella in building water systems for 30 years, at the beginning, there were 2,000-gallon storage tanks. And we said, aha, let's remove those storage tanks and switch to instantaneous heaters where the cold water coming in is flash heated to 180 degrees and blended down. And we got our hopes up that something like that would rid the outlets of Legionella. And I'm sure you know that the answer was no. Even though the water going out was at 140 degrees and it was coming back at 130, what happens out there, and your point about in the delivery pipes, temperature goes down and Legionella lives happily ever after. And we look at particular interventions that we've tried over these years to solve this problem without supplemental treatment of the water. And other than a barrier filter at the tap, I'm not aware of any magical intervention that has controlled these issues. And so I think your point is well taken, that we need to start thinking about the fact that when the laws that say water quality to the wall, where that water enters the building, brings it to us at a certain quality, and that's mandated, but when it crosses that wall into the building, it's not mandated anymore, and we know that it deteriorates. And so I think we're coming to a point where there are a number of interventions that can help, but I think we do need to seriously think about the fact that some buildings, like healthcare facilities, probably do need supplemental water treatment, and we haven't found the best one yet, but we're working on it. So I think that we need to consider that as something of a solution under certain circumstances, certainly not in every building because the risk is not sufficiently high.
Go ahead, Joe.
On the matter of decentralized treatment, which is what you're getting to on point of use, point of entry. In the U.S., the Safe Drinking Water Act actually allows community compliance for certain kinds of contaminants by decentralized treatment. Now, for microbial contamination, the only acceptable approach would be universal point of entry treatment. But for some others, like arsenic or some metals and such that aren't going to be changing much, point of use treatment can't be used. But there are some logistics issues and some economic issues. Now, in a small community, and I actually ran a project testing out decentralized arsenic treatment in a community in California of about 200 people, and it works great, and it's less expensive than centralized treatment in a small community. But the crossover point probably is about 400 residents, something like that. Because when you get above that, then the economies of scale and so forth just take over. So, but what I was getting to earlier on when I said, what's water supply going to look like 25 years from now, 50 years from now, really does include that as something to consider. Because when what we are doing now in water supplies, in the US at least, is we're chasing nanograms per liter of contaminants. And in a couple of years, there'll be picograms per liter, and it'll just keep on going. So we'll always be finding something in the water. Now, does it make sense to treat the water at the plant to that fantastic distilled water quality, basically, and then put it in a distribution system where it's going to pick up microbes and other kinds of contaminants? Because when it gets to the tap, it's not going to be the same as it was when it left the treatment plant. So I think it's a serious question. You know, what are the alternatives that can be considered for providing drinking water at the tap that is high quality? Now, it's safe now. It's safe now. But it may be that there are some other approaches that may sort of bridge the gap from the central treatment to bottled water that will make the public more comfortable, let's say. But there's always a question of cost effectiveness on how do you do this.
Your question was quite long and you covered quite a lot of things. And I'd written down at the beginning, you asked a question about materials. And I think basically you said, when we get these outbreaks or we have Legionella problems, do we ever take the devices apart and work out where it is? The short answer to that's yes, and I can remember at least one PhD thesis from 20 years ago that was essentially about doing that. The positive thing we can learn from that is there are certain materials that tend to support microbial growth, support and encourage it, and others much less so, and regulation can and does target the use of materials in supply systems which don't favour microbial growth. And that phrase I used with Karen was one of the themes I wanted to come back to later in our discussions here, that Legionella is serving not only in our discussions here, not only as a pathogen that we're concerned about, but also as an indirect signal for other growth problems and issues from growth, health issues that may arise from growth of other microorganisms and potentially microorganisms that we don't yet recognize, potentials we may not recognize. And so the idea of focusing our control strategies on two things. Firstly, minimizing the risk of excess microbial growth, and that involves controlling the kind of factors that we've discussed here and the materials that we use to construct our systems, and minimizing exposure through whichever exposure route is most relevant, and in the case of Legionella, that's inhalation. We've got more than one way to reduce risk, and we ought to be targeting both, not one or the other.
Yeah, I think as I listen to you folks in answering that question, I hear there's no silver bullet. I know we'd like to have that and would like to hear that, but that doesn't exist. And maybe to highlight actually what Jamie just said and others is I'm hearing keep it simple, understand your system, and understand the risks of that particular system, and then take appropriate steps to minimize the risks. And although that is more difficult than it sounds, there's no simple answer to the problem, I think is what I'm hearing. Any other questions from the floor?
Yeah, Jim, Bob Simpson, member of the board of directors, and also I'm the chief plumbing inspector in Lincoln, Nebraska, and my question's more to Jim than the panel.
Uh-oh.
Yeah. Is the engineering community...
Yes, University of Michigan beat the University of Nebraska in football. In case you missed that game.
No,
okay.
I saw all of the game, but... yeah, never mind. Anyway, my question is the engineering community cognizant of all these problems and concerns that were being addressed today? And the reason for that is, as a plumbing code official, if I go out to a job and I tell the contractor he's got to do something a certain way to prevent some of these issues, he's going to say, show it to me in the code book. And if it's not in the code book, I don't have any leverage to speak of. Whereas if it's in the specs that the engineer had spec'd out for that job, then they have to follow those whether they like it or not. And that's my question to you.
Yeah, I think, and just, you heard my background, I'm not an engineer, but in answering your question, and what I'm seeing is The engineers are asking the same questions, and they're saying, how can we design better systems to address the issue? And so that's a good thing. And I know we've recently gotten more involved in, from ASPE's perspective, in the work that Bill and Tim have been actively working on at the ASHARE and getting the engineering perspective more present in that. So number one, we can learn from that and what's been going on, as well as provide advice and guidance. So to answer your question, I think, yes, the engineering community is engaged, and they're committed to designing systems that help solve those problems or reduce those risks, and learning just like everybody else at this point. I know we have, Tim, you're an engineer, and others, if you have anything to add to that.
I would like to politely disagree.
I knew you would, Tim.
I think engagement, I think Jim is partly correct. Engagement has begun. But as I mentioned in my presentation, you buy a hot water heater, you will see a full scale, a full page thing about scalding. You won't find anything about Legionella. When I do outbreaks and I go into a building and I'm in the boardroom and I'm talking to the chief medical officer, I'm talking to the CEO, I'm talking to the design architect that was involved in the design of the building, I'm talking to the chief plumbing engineer, and I'm talking about what caused the problem and the plumbing issues, and their mouths are all hanging there. And this is common. So yes, there is better engagement now than ever before, but awareness is still a huge issue. Case in point, there was an article that came out in AWWA magazine, American Waterworks Association, I think it was a January issue, about Legionella in hospitals. And the author wrote that he had surveyed hospitals and found that about 60% of hospitals actually had a waterborne pathogen risk management plan in the building, and about 35% of them actually had it in use. I called up the person that wrote that article and I said, do you know that hospitals are required by code since January of 2001 to have a waterborne pathogen risk management plan in place? Is that what the genesis? And he said, no, I didn't know that. So here's an industry where they've been required since 2001, and a lot of them aren't even aware of it. So increasing awareness is definitely an issue that I think would have a huge impact. And something Janet said, she mentioned that there's going to be a cost to this. And I think there will be a cost initially. But having a lot of bacteria in your system is really a symptom of a plumbing problem. And if we have systems that have, over time, are designed better, and we have smaller pipes, we're going to save, I believe, a lot of money in costs. If we turn the water over better and have less aging problems, that means we have better sizing and better component issues. And we're going to have lower square footage used for plumbing. We're going to have lower initial capital costs for plumbing. And we're going to result in better plumbing systems with lower bacterial issues. So I think this increased awareness long-term is going to help reduce plumbing costs and infrastructure costs.
And Tim, we're in agreement. I totally agree with you on the awareness factor. You are absolutely correct. Jamie?
Briefly, I've come relatively recently to the world of training or teaching of engineers in the US. I mean, I've been working in a Department of Environmental Sciences and Engineering for just two years. And as a comment on this discussion, I think I see a tension which is not necessarily explicitly recognized. And that's despite the fact that I'm in a department which is unusual in that it is an engineering department hosted within a School of Public Health, which means that our students are more exposed to these issues than you might find would be the case elsewhere. And the tension is a perennial one. It's to what extent the structure we're working in is one that's driven by what needs to be achieved, and to what extent it's one that's driven by a statement of how it must be achieved. So either what it is or how to get there. What I see is that what we desperately need are engineers who understand how to reach a goal. because the tools we have available are changing so rapidly now that we need the ingenuity and the adaptation of individuals, that they can respond to the changes in different technologies and tools, and those include management tools as well as hardware tools. When we see regulations that are written that stipulate how an outcome is to be achieved, it stifles that innovation and stifles the creativity of the engineers that we're putting in the place to try and do things better. So it's a comment on the debate, but it seems to me there's a tension that we don't necessarily recognize and we don't necessarily respond to.
Having us all recognize the same goal.
It would be good that we work to
Would be
goals
good.
rather than steps.
Joe?
Having once been a regulator,
Can you say that a little louder, Joe?
having once been a regulator, and a reluctant one, I think in that tension that Jamie's talking about, in this system, in this legal system, it just doesn't accommodate freelancing. It's, you have to have codes. The key is to have them all up to date, to really make them living codes so that they can be agreed to, documented, communicated to the practitioner, and then applied. But I don't think very many practitioners would survive very long if they were out there sort of superseding codes, because as soon as that first mistake happened, they'd be in very big financial trouble, if not more, if not even, criminal trouble at some point. So the tension's there. It has to work. They have to work together, but we have to have the codes, and we have to keep them up to date.
Anybody else?
Well, what I wanted to say was, in the scenario he speaks of, we have authority having jurisdiction, probably an engineer in the picture, a contractor in the picture, and possibly the owner. So without that communication between them, without someone in that group being informed as to the situation, and it may be hard to believe, but sometimes in those kinds of meetings it might get a little adversarial. You need to have a good relationship, and people need to understand and plan these things out. And you're correct. If the code does not dictate it, if the design was not set for this, the contractor has to do what the design is. The plans are approved by a higher authority, giving you a state plan release or a construction release or whatever that might be. You are very limited in your freelancing ability, but if you have the conversation, if you get the parties together and demonstrate the studies and the information and where these errors are, then they can be corrected. But you have to have good communication among the parties.
I know one of the comments that came out of yesterday's meeting we had with all the stakeholders in plumbing leadership was that, and this came from an engineer saying, we have to take a more active role or proactive role in the development of codes and making sure that they have a sound engineering basis to them as well as all the other things. So, Dave, Dave, would you like to ask a question?
I would.
Pete keeps pulling me over there, so I'm sorry.
Well, Pete's that compelling kind of guy. Dave Viola from IATMO. We all know that IATMO develops the Uniform Plumbing Code, and we're talking about codes. And throughout the discussion today, we hinted at some opportunities for change to address issues that we're talking about and are being elevated. Well, now that we're elevating them and talking about them, IATMO has a process every 3 years to deal with changes in code to keep up with health and safety issues. So my question is, where do we go from here with the group that we have assembled here as far as taking the information that's been identified and that we're going to learn moving forward and translating it to actual changes to the code and standards? So that question, where do we go from here, based on some things like pipe sizing was identified as a potential issue, materials, water temperature changes, design practices, too many fixtures in hospitals. I was kind of keeping a mental list of things that were identified. These are all code-regulated items. I'd like to see and hear discussion about what can we do to deal with the codes now, and maybe set an action plan for changing them based on things that are occurring within ASHARE 188, and what's in ASHARE 188 now that can translate to code changes today, and what's in the hopper that we can be working on, maybe task groups, to address changes for the future. So, it's a bit long explanation for a simple question: where do we go from here? Anybody?
I'll mention one thing. I saw a paper recently and talked to some researchers at a university about a study on hot water return systems. And we know hot water return systems consume a ton of energy. And they had published a paper that said there was less Legionella in systems without hot water return than systems with hot water return. Now, I found that fascinating, and I didn't believe it either, but I think there's some truth to that. Now, their study was on individual homes, and that makes sense. Not many people have hot water return systems. And when you think about it, the logic behind it, you have a hot water return system that, say, it's working 24/7. You're circulating water during your no demand period, say from 10 o'clock at night to 5 o'clock in the morning. Nobody's using the faucets. Nobody's pulling that hot water from the headers and the risers. So if the hot water return is running during that period where it's consuming the most energy, because there's no use of the water, it's basically keeping those drop legs tepid. And what would be the potential of maybe coming up with a code, or people doing research, as I know they're doing now, of turning off those hot water return pumps during the low use periods, running them constantly during the high use periods, so when the drop legs are used, we know we've got hot water at the drop leg and we've got the disinfection capability of that hot water. And when the water's not being used, maybe allowing those risers and headers to cool and those drop legs to cool way below the 85-degree point might actually give us lower bacteria and huge energy savings. So I do think there is definitely code improvements that can reduce energy and reduce Legionella at the same time. And I know a lot of people were working on things like that.
If I could just interject a sort of a scientific cautionary note. I think one of the next steps in terms of code would be to gather information that supports, from a scientific point of view, what's been done and shown in the literature that supports changes in code, whether it's temperature or pipe size, and then evaluate that information before you make those changes. And if your organizations are in a position to support the research that can provide the data to show that those changes in, whether it's temperature, pipe size, or whatever, or materials, actually will reduce the chance of Legionella or other pathogens being there, then you're making a code change with a lot of confidence that if that code change translates into some cost, then that's money well spent. I worry sometimes about taking action before we have the information to show that these changes will have an appreciable effect. So I just want to interject that little caution.
Jim, do you mind if I just support that comment really strongly? I've spent too much of my life either having to undo issues that have been put in place, code components, if you like, with the best of intentions, but with no evidence, and which over time we've learned not to be sound. And at the same time, we've also seen instances where codes have been insufficient, and this is nothing specific to IATMO, it's a nice general comment, where codes have not been sufficient to protect health. And the idea that we need to be more aggressive in linking the evidence base to the specific requirements of code, but also turning around where we have areas where we believe that code is needed and there is not a sufficient evidence base. Let's make it clear to the researchers so they can fill those knowledge gaps. There's not that many of them, but those that we have are probably critical.
Yeah, and I can't, I've sat on many a standards and code committee where somebody finally asks, where's the research? Where's the scientific rationale for supporting one's opinion? And I have to take my hands off to IAPMO. You know, it's IAPMO, for instance, has stepped up, and ASPE has joined them in looking at the question of pipe sizing. I take my hands off to the Plumbing Efficiency Research Coalition on looking at the issue of low-flow devices and just down, you know, the impact of drainage systems, which we're going to be seeing a study here results pretty soon. So there is research going on, but I would say not enough. And one of the issues that came up yesterday is trying to find the funding for the research. We could come up with 1 million research projects and no money to do it, but good points. Dave, did that?
Everything except for what you said.
Okay, I'm okay with that.
Well, I did want to point out a couple things related to your comments that the Green Plumbing and Mechanical Code Supplement does have sections for demand-initiated recirculation so that we don't have recirculated hot water systems running continually, that you trigger it to run as needed so that you will not be circulating that water continually. And these days in larger houses, it is pretty common that we're seeing recirculation hot water systems going into residences, that's being asked for more and more. As houses get larger, it takes significantly longer to get hot water to places. So some of that is happening already.
Yes, Bill Hoffman Associates. I'm going to make a statement and then follow with a question. My statement is I believe in the 25 years from now, where are we going with this? We're going to see a quite different view of water systems on a property, because they will include multiple sources of water, including the use of on-site sources of water for irrigation and other non-potable type uses, or maybe rainwater for even potable use with proper treatment. I'm going to a couple of quick things. Like that whole area in our code, many of you may know Dr. Bob Rubin and the great work he did with NSF 350 standards and that whole committee. We have a lot of different things out there. We have a whole different type of system that's going to be out there. There are going to be a lot of questions. I'm reminded of the guy who said, you know, I didn't know you needed an answer to that question. And the other one said, well, I didn't know you had a question to that answer. And you said one other key word out here, and that was silos. This is my question. How do we get the right silos talking to each other so that the right questions are answered in all of these issues, whether it be Legionella or other the treatment things when we get to the health and safety of all these different water systems we're going to have in the future?
Well, I look forward to your answers. Anybody?
This is Washington, you know. There are so many silos in Washington that, you know, there are silos within agencies also. It's a really tough one, of course, as you know. Just a comment, though, on, well, just a little more on that. I mean, the idea of having code writing organizations like IAPMO is extremely good, because that's the opportunity to bring everybody together to arrive at good judgment. So at least there's some hope there, and it needs to be expanded. On the matter of the 25 years from now, the methodologies, where are we going to be? Well, everything you mentioned and everything that everybody's ever talked about here leads to much, much greater complexity. I mean, we're not talking about simplification. You know what? We're not talking about, you know, add chlorine, kill the organisms. We're saying, well, you know, control the temperature, control the size of the pipe, control the dead volume, control the surface materials, et cetera, et cetera. And so what that means is life will get more complicated, and the business of plumbing and codes and supervision will just become infinitely more complex. And everybody's going to need some kind of an advanced degree plus regular updating just to try to keep up with it. It's unfortunate. The way I look at it is, look at your home, your TV and your computer and all that. 20 years ago, you turn the switch on and the TV came on. Well, now it takes you quite a while to figure out how to program it and all that other stuff. Think about the analogy here.
Very quickly, I could say I know silos are a huge issue. I think if we get more awareness out, it will help. I got an email a few weeks ago from an ASHARE 188 member about a guideline that was being written by ASHARE. And it was a conservation grade guideline, and she said, this kind of looks like there's issues. What do you think? And I said, yeah. So we kind of picked this up by chance. I think she may have been on the committee. But even with our own organization, there are communication issues. So I could see where there's communication issues, and unfortunately it's a problem between codes people and operational people and design people. And the only thing I can say is hopefully we can get Legionella from no longer being the Rodney Dangerfield out there, and give it some respect, waterborne pathogens, and have it on top of the table and people talking about it, and maybe that'll help reduce some of these silos.
I'd like to follow up on this silo metaphor just a second. And I think about silos, what was discussed in regard to the metaphor really was maybe a high elevation look at the silos. People who are very well informed, educated engineers, regulators, and so on. That's the top of the silo. But that silo goes all the way down to the people in the real world who are dealing with facilities. And so I think what we should all be very hopeful about is, as voluntary consensus standards are developed for what to do about the problem, people at the bottom end, let's call it, the ground level of the silos, realize, first of all, that they are responsible for this problem, that they really do need to understand how water is processed in their facility, that they really do need to manage any control that's applied. That's when the silos begin to severely break down. Severely is the wrong word. Productively break down, because then the people who are at the ground level realize they do need solutions for monitoring. They do need solutions for exactly what they're going to do about testing. So I think, just to conclude on that metaphor thing, is one of the things that has been missing is a voluntary consensus standard about what to do. That missing component is about to change. It's about to be filled in. And I think we should be optimistic that this will help break down silos.
Anybody else? I was just, oh, go ahead.
This is Peter.
Is that a line behind Peter? Oh, okay. I'm just trying to gauge the time.
This is Peter Cartwright with Cartwright Consulting. I really have two questions. The first one I think I'll direct towards Janet, and that is, Janet, what is the minimum water temperature at which you might realize, let's say, 6 log inactivation of Legionella bacteria?
You're not going to like the answer. It depends. We've had a long discussion about temperature and log kill of Legionella on the Guideline 12, ASHARE Guideline 12 committee, because I'm the author of one paper from back in the 80s where we actually calculated log reduction at certain temperatures, 50, 60, 70, 80 degrees centigrade. And that's in a beaker, okay? And you can get a 1 log reduction at 50 degrees in a couple of minutes, but in a pipe, it's a different world altogether. And I don't know.
What about a water tank, hot water tank?
Or a hot water tank, right. So, a hot water tank that's got cold water going in the bottom and hot water going out the top and doesn't have good movement of water. You've got lots of temperature stratification. So you might have a temperature gauge at the top saying it's going out at 140, but half the tank is at 120 or something like that. So I always get a little nervous when I'm asked to pinpoint a temperature.
Well, my second question is that Tim talked a bit about the scalding potential of hot water, but what I see, at least based on where I live, there's a lot of consumer blogging from the energy companies saying, turn your hot water temperature down, save energy, turn it down. Nothing more than 120 degrees Fahrenheit. And so I'm wondering if we're going to shoot ourselves in the foot by increasing the incidence of Legionnaire's disease because the hot water temperature is too low.
You know, going way back to when my career in Legionella started in the early 80s, I don't know if you recall, but there was an effort to save energy then by reducing temperatures. And it was actually speculated at the time that that action on a large scale contributed to an increase in Legionnaire's disease, to the point where there was actually, by the Joint Commission, a statement to hospitals saying, you know, you guys can set your temperature because we don't want to tell you to maintain at a low temperature because it may be contributing to these problems. So I think that your logic makes sense. So we have to be careful about weighing the energy issue versus the public health issue.
This is anecdotal, but I, probably sometime in the 90s, turned down the water heater temperature in my home, like everyone else was doing. I tested for Legionella in my water heater and found lots of it. I turned the temperature back up to where it was before, tested again and found no Legionella. Now that's anecdotal, but I think it's, perhaps fairly common.
Talk about the future and design and whatnot. You can go on the web, or you guys probably know it. You can buy an industrial hot water heater that has automatic controls on it to turn down the temperature at nighttime. Talk about low fruit. Now, I don't have any data that this works, but my guess is it does. And that it would be nice, and you cannot buy a residential hot water heater that has that type of control. I looked, I tried. So low-hanging fruit, maybe you want to run your hot water heaters, say during your shower period in the mornings at 130 or 140 degrees. A couple hours a day, kill the bacteria. At nighttime, drop them back to 95 degrees. Save a lot of energy. Those components are available on our HVAC controls in our homes. They're available on industrial type of residential hot water heaters, but they are not available today on home hot water heaters. So there are ways to do this logically, but we do need to study it and ensure that it does do what we think it'll do.
Hi, I'm Rob Zimmerman with Kohler, and I just had a question for the panel. You talked about some strategies to help mitigate the growth of Legionella in pipe systems and faucets and such, about age of the water and flow rate and the turbulence and those kind of things. I was wondering if those same strategies would also apply to other pathogens that could be in the piping systems, or do we have to have a series of strategies depending on whether they like warmer water or cooler water and the resistance to different antimicrobials that might be in the water? Just interested in your comments on that.
A very brief response. That was the comment I was trying to make earlier, that I think we need to see Legionella as both a hazard in its own right and as a signal, a very crude indicator for other potential hazards as well. Some of those we know something about, and some of the classes of pathogen that can grow in water systems may be slightly more or slightly less resistant than Legionella to some of those specific conditions. I think, and I'd like to look across at Janet and see if she's going to nod or shake her head as I say this, I think we need to recognize that there are probably more, and possibly many more, growth pathogens that we don't yet know about and we haven't yet characterized. Is that not? Yeah, I got a nod, I'm doing okay. And therefore the general idea that we have a response which is an attempt to minimize the risk from bacteria, from microbes, primarily bacteria, which grow in water, is a good thing. I don't think we should assume that fine-tuning, calibrating our responses on Legionella will necessarily deal with everything. I mean, a 5-degree difference in temperature tolerance, given the conversation we're having here, could make a very big difference. But the general approach, I think, is sound. We need materials that don't foster growth. We need temperatures that tend to inhibit growth. We need to minimize unnecessary stagnation. We need to minimize mobilization of growth in a way of biota in a way that leads to human exposure. And our discussions here have tended to focus on reducing growth. Growth alone does not lead to disease. We need both growth and we need human exposure. And in the case of Legionella, that's through droplet or aerosols. We can also reduce exposure as well as reduce growth. And I would again suggest that we should look at both of those options together, not one in isolation.
Anybody else? Oh, Bob.
This is Bob Bulware with American Rainwater Catchment Systems Association, and also a proud member of the IAPMO Green Technology Committee that helped develop the Green Plumbing Supplement. As we start adding alternative water sources into the codes, the concept is for water is fit for use. When we start adding alternative water sources and non-utility provided water, the concern always seems to be, well, what about the aerosols created when you flush a toilet? There's been no research that I could come across that relates to that topic. Is there any validity to that, or is that just an urban legend?
Just as to comment, Chuck Gerba has made a living out of doing things like that. If you might remember, there's this sort of quirky microbiologist who has been on several networks, going around hotel rooms and, taking swabs. And one of his areas of research is he has actually measured aerosols coming off of toilets. And he recommends closing the lid before flushing.
And don't leave your toothbrush in the bathroom.
Right. But the other thing he finds is
But
that...
he actually has videos, doesn't he, Joe?
Oh, yes.
Yeah.
The whole works. But the other thing he says, by the way, is the greatest level of contamination is found in the kitchen, not the bathroom. Damp rags and surfaces and things like that. So stay out of the kitchen, I guess. And, well, that you don't have a choice.
If I can indulge the board with just one more question, it's just to Dr. McCoy and possibly Dr. Stout. Your comment about your Legionnaires' disease went to 0 when you raised the temperature from 85 to 120. Can you say for certain that that was because you raised the temperature, or is it because of the change in temperature? Kind of speaking to a little bit more what Mr. Keane is saying, that varying the temperature seems to be a factor in controlling biology.
Well, a couple of things. One is I didn't say anything about the disease, Legionellosis. I only said that I had simply tested for the presence of the bacteria in my water heater. And the other thing is I didn't say anything about temperature. In fact, I didn't even measure it. I just turned the temperature down I didn't measure it, I just turned it down. This is very anecdotal. And then I measured and saw Legionella in the water tank. There was no disease, there was just the bacteria in there. Then I turned the water heater back up and then didn't find Legionella in the water tank. And I was only offering that as just an example of how thermal effects can affect the viability of Legionella, but I didn't mean to extrapolate forward towards prevention of disease.
Okay, we have 5 more minutes.
Yeah. Hi, Steve from Ditector. Just to complicate things more, all your discussions and expertise are on Legionnaires on the supply side of water. When there's an outbreak, you can clean the system, but have you ever looked at Legionnaires in the drainage side and other pathogens that can spread throughout the building by transient movement? So when you do, particularly to Tim, if you do an investigation in a hospital, you look at the supply side and the taps, but have you also looked at the floor drains, the toilets, the sinks, the pipework on the drainage side? Because a drainage system is never 100% full. It's 25 to 75% full, and the temperature range is the perfect environment for continuing the growth. So cross-contamination can reoccur.
I'll do something short, and other people may want to say something. Regarding the toilets and the spray, I agree with what was said. The only caveat I have on that is a thing that concerns me is if we look right now, if you test the toilet, typically toilet water in a building has the lowest bacteria count, and there's been people that have shown that, and I've done that, and I've found the same thing. But if we go to recycled water in toilets, where we're using water that may be treated but full of organics and nutrients, I'd be real concerned about what potential that change has. And then as far as water drainage and whatnot, I've had people say, you know, I've got a pool of water on my rooftop and it's somewhere near my HVAC system. What do you think about that? Legionella has to be aerosolized. Now, there are other bacteria or airborne bacteria. Legionella is a waterborne bacteria. It has to be aerosolized as a water droplet. So unless you're sucking water droplets out of your drainage pipe, the potential for Legionella is next to nil. Now, mold and other things that can grow in that drainage pipe are airborne. They don't need water particles to be spread. So those are an issue, but typically Legionella, you have to have water droplets. I didn't hear that.
Water droplets do occur, basically.
You have water vapor in the drainage system, so it does occur.
Well, I'll tell you one case where I know what you're talking about. It is an issue that has a concern for me. HVAC systems, air handlers. Air handlers that have cooling systems will condensate water, and they have drains in those air handlers. And those drains should, under a negative pressure, educt the water out of the drain and put it to drain. Frequently, those don't work. And we do know that you'll get aerosol out of those drainage systems, and that aerosol will go in your HVAC system. Now, typically, your air ducts are cool, your air handlers are cool, and when you're having this condensation, it's not during the winter time, it's during the summertime, and you have your cooling and air conditioning on, so you have less chance of bacteria growing. But I've actually seen situations in hospitals too often where they'll have pleated paper filters downstream of the air handler unit. And the paper filters are gone because they became so waterlogged that they dropped. So that I see is a real issue if you don't maintain air handlers and you get carryover from your basin. Potential for Legionella is low because they should always be cool. But other bacteria, other pathogens are significant. And I can't think of any other drain where you would have the potential for aerosol other than an air handling unit basin.
Well, as a good moderator, I'm going to say, you know what? You guys can carry this conversation on.
I'd just like to end it because I say that SARS was the perfect example.
Okay.
Jim, can I ask a quick question over here, Janet? Over here.
Oh, Janet.
Just before we leave, because it's just sort of nagging at me, for the panel and anyone else to comment on, and it's sort of a famous Dustin Hoffman line from a movie back in the 60s. It's plastics. And, we heard lectures this morning about, binding plastic pipe, and there's ProPress, and there's clearly an economic advantage to getting away from copper. But from a microbiological point of view, I wonder if anybody in the group or the audience wonders about 25 years from now, when we don't have copper pipe delivering our water and it's all plastics, the impact of that in terms of the microbiological quality. Anybody besides me concerned about that?
Wow.
That's the last question.
Yeah. We'll talk about it over drinks tonight.
Yeah. Andy, keep quiet. Anybody have a response to that you can do in less than 30 seconds?
I'll be really pleased to see the back of the lead solder that joins the copper pipes together.
Bring it back. Is that it?
Okay. Yes, simple answer, Rich. Go for it. Okay. Yes.
Yes. Okay.
All right. I'm going to, if you have, it's a good question. And so if you want to answer that with Janet later on or discuss that with her, please do. But it's my role to make sure we end up on time, and we have reached that point for us to turn it back over to Bob. I just wanted to close with two things, and one is In all fairness to Jamie, I mentioned that when I last saw Jamie, he had a ponytail. Well, when Jamie last saw me, I had brown hair. So, and I personally think it's still brown, but my grandchildren tell me otherwise, so I, you know, but so in fairness to you. But I think the last thing I think, and the issue was with silos. I think an event like this is such a major step forward in reducing those silos. And thanks to IAPMO and the World Plumbing Council for doing this and bringing us all together, and all the sponsors, because this is how we reduce silos. And thank you, the panelists, and a round of applause for